on to the final type of question in binomial theorem. It's questions that requires you to find n. Before we can look at examples of such questions, there is one new formula that I need to introduce to you, which is the formula for n choose r. You know, all this while we've been using our calculator to evaluate n choose r, but the type of question that we're going to look at today, the n is unknown. Therefore, you cannot use your calculator to evaluate n choose r. Instead, you have to convert n choose r to a fraction, and then you can manipulate that fraction using algebra. Let us look at the formula for n choose r first. N choose r is given by this formula: n factorial over r factorial n minus r factorial. Now, of course, some of you may not be familiar with that exclamation mark. The exclamation mark is actually a mathematical symbol, and it's read as factorial. The meaning of factorial, let's say I have 5 factorial. This means you take the number 5 and you multiply it with consecutive numbers, consecutive descending numbers. So it starts with 5 and then you multiply with the next one, which is 4 and 3 and 2 and 1. So if you have 7 factorial, then it will be 7 times 6 times 5 times 4 times 3 times 2 times 1. Of course, we can also write 5 factorial in another way, which is we start from 1 and then we multiply in ascending order until we reach the number 5. We can evaluate factorial using our calculator. You have to look for the x factorial button. So let's say if I want to use the calculator to evaluate 5 factorial, now I will press 5 followed by the x factorial button. I think you're going to get 120. So now that we understand what factorial is, let us get back to the formula. Let's say I want to evaluate 11 choose 8. In that case, my n is 11 and my r is 8. My n minus r is 11 minus 8, which is 3. Therefore, 11 choose 8 is n factorial, 11 factorial, divided by r factorial, 8 factorial, and n minus r factorial, which is 3 factorial. Of course, I can use my calculator to evaluate all the factorials here, but I'm not going to do that. Instead, I'm going to simplify all the factorials and show you that we can actually do some cancellation. 11 factorial, we know that it is 11 times 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. 8 factorial, I'm going to leave it alone, but I want to simplify 3 factorial. And we know that 3 factorial is 3 times 2 times 1. Next, look at this is 11 factorial and this is 3 factorial. But you can see that inside 11 factorial, I have 3 times 2 times 1, which is just 3 factorial. So that tells me that I can actually simplify the numerator and denominator by cancelling away my n minus r factorial. But before we do the cancellation, I want to bring your attention to the number before. Okay, this number here, 3, is your n minus r. So this is n minus r. I want to bring your attention to the number before n minus r, which is the number 4, this number. If 3 is n minus r, then we can say that 4 is n minus r plus 1, because 4 is just 3 plus 1. And this number is actually the last number that is not cancelled away. Okay, so now the next step, I can simplify my 11 choose 8 by doing cancellation. I can cancel my n minus r factorial here and my n minus r factorial here. Then what I have left is just 11 times 10 times, now I'm not going to write down all these here. I'm just going to represent them using dots, dot dot dot, times 4 and divided by 8 factorial. This is another way to evaluate 11 choose 8. Using this example, we can write out another formula for n choose r, n and r. The denominator is quite straightforward. The denominator here is 8 factorial, which is just r factorial. The numerator requires a bit more work. We know that the first number is 11, which is actually my n. So I can say that the first number is n. The second number is 10, and there is my n minus 1. And then the next number will actually be n minus 2, and so on. But I just represent them all with dots, times the last number. We know that this last number here is n minus r plus 1. Because n minus r onwards, they are all cancelled away, because the denominator is n minus r factorial. So the last number that is not cancelled away is n minus r plus 1. This is another formula for n choose r. So let me show you how to use this formula. Suppose I want to use this formula to evaluate n choose 4. There's a very easy way to remember this formula. To get n choose 4, you write it out as a fraction first. You write n over 4. I draw the line longer because I need to do some multiplication later. The next one is n minus 1, n minus 2. Now, of course, we know that the last one is n minus r plus 1. And over here, we have my r is 4. So it's n minus 4 plus 1, which is n minus 3. So the last one is actually n minus 3. And there is actually an easy way to remember when to end. It really depends on this number here. If this number is 4, that means that I'm only going to have 4 factors. Like you see here, I have one factor, another factor, the third factor, and the fourth factor. So if it's n choose 4, I will only have 4 factors. And then the denominator is also 4 factors, because it's 4 times 3 times 2 times 1. So n choose 4 means I will have 4 factors in the numerator and 4 factors in the denominator. Let's verify that with another example. Let's say now I want n choose 6. Now we're going to write it as a fraction first, n over 6. Now n choose 6, n minus r plus 1 is n minus r is 6, so it's n minus 6 plus 1, which is n minus 5. Now I've already told you that if this is a 6, I'm going to have 6 factors in the numerator and 6 factors in the denominator. Let's see if it is indeed this case, and see we end at n minus 5. So this is, the first one is n, the next one is n minus 1, n minus 2, n minus 3, n minus 4, n minus 5. You can see we have 1, 2, 3, 4, 5, 6 factors. And the denominator is of course 6 times 5 times 4 times 3 times 2 times 1. So we also have 6 factors. 1, 2, 3, 4, 5, 6. Okay. So to know when to end, there are 2 ways to do it. If you want to know which is the last factor, you can either work it out using this n minus r plus 1, or you can just remember that because this is 6, you're going to have 6 factors. So you just end once you have 6 factors. Alright, with this we are now ready to look at some examples. Let's do the first example. Let me paste the first example in. Example 1. You can see here your n is unknown. The first thing that I need to do for this question is they tell us that when we expand the left hand side, we should get this. So of course I'm going to do my expansion, 1 plus px to the power of n. But I will only expand it up to x cubed. So if you do your expansion, you're going to get, let me do it quickly. I only want up to x cubed. I think I only need 4 terms, 1, 2, 3, and 4. So only 4. Now this one, when you simplify it, there's a lot of things that will actually just simplify to 1. Because n choose 0 is 1. 1 to the power of anything is 1. And anything to the power of 0 is 1. So the first term is just 1. The second one, n choose 1. I'm going to leave it as n choose 1. And 1 to the power of n minus 1 is just 1. And px to the power of 1 is px. The second one, n choose 2. n choose 2. And then this is 1. So I'm left with p squared, x squared. Plus the third one, n choose 3. And this is 1. And then we have p cubed, x cubed, plus ... This is what I get when I do the expansion. And the question says that the expansion equals 1 minus 32x plus 448x squared plus qx cube. So let me equate what I have found with what is given. Now to find the value of n, p, and q, I have to compare coefficients. Comparing the coefficient of x, I can say that n choose 1, p equals negative 32. Comparing the coefficient of x squared, I can say that my n choose 2, p squared equals 448. This is equation 2. And then finally, comparing the coefficient of x cubed, I can say that n choose 3, p cubed equals q. This is equation 3. Right? Now I have to solve the 3 equations simultaneously. But before we do that, we have to change all these NCR into fractions so that we can work with the 3 equations like any normal algebraic fractional equations. So therefore, from equation 1, n choose 1 is just, if you remember, n choose 1 is just n over 1, and then because it's 1, so there's only one factor, so it's basically just n. So np equals negative 32. From equation 2, n choose 2. n choose 2 requires more work. We write it as a fraction first, n over 2. But because this number is 2, so there's going to be 2 factors. Therefore, the numerator is n minus 1, and the denominator is 2 times 1. Therefore, from equation 2, I have n minus 1 over 2 times 1 is just 2. So let us just write it as 2. And times p squared equals 448. Then from equation 3, we have n choose 3. n choose 3 is, we write it as n over 3. And because this is 3, so we're going to have 3 factors. So it's n minus 1, n minus 2. And then this is times 3 times times 3 times 2 times 1. So therefore, this is n minus 1, n minus 2 over 3 times 2 times 1 is 6. So it's 6p cubed equals q. So let me name this equation 4, 5, and 6. Now equation 4, let's just simplify this a bit first. I'm going to make p the subject. So let's call this equation 4. And then I have this equation 5, which is in terms of p and n. So let us substitute 4 into 5. I'm going to work this out very quickly. n minus 1 over 2. P squared is negative 32 over n squared, 448. What I've done is I've changed equation 5, which has 2 unknowns initially, p and n. I've changed it into an equation that only has 1 unknown. And I can now simplify this. So this is n minus 1. 32 squared is 1024. So 1024 over 2 times n squared. Now I found my n. Then the next step, I can substitute this back into here to get my p. So therefore, my p is negative 32 over n, which is negative 4. And finally, I have this equation for q. So I can substitute n and p to find my q. So that is n minus 1, n minus 2, n minus 1, n minus 2 over 6. Let's string this a bit. Over 6 p cubed, which is negative 4 cubed. And that gives me negative 3584. That's my answer for example 1. So basically the idea is just to compare coefficients, which is what I've done here. Compare coefficients, and then because the coefficients, we have n choose 1, n choose 2, and n choose 3. This is where we use the formula to change them to fractions like this. And then we just solve them as fractional equations. Right. Next, let us move on to example 2. Example 2, we have a product of expansion. And they want you to expand it in ascending powers of x up to the term x squared, where n is again unknown, but they say that it's a positive integer that is greater than 1. So let me just very quickly do this expansion. This one I want it up to x squared, so I only need, I think it's just x to the power 0, x to the power 1, and x to the power 2. So 3 terms plus dot dot dots. Now the second one is 1 minus 3x to the power of 2. We can use the formula a minus b square is a square minus 2ab plus b square. So that gives me, here, let me fill in the blanks. First one simplifies to 1. The next one is nx. Just n choose 1 is just n. It's n over 1, so it's n. N choose 2 is n over 2, but because the number is 2, so I have 2 factors, so it's n minus 1 over 2 times 1. And then x squared plus dot dot dot. This is 1 minus 6x plus 9x squared. So next I need to do all my expansion. There's quite a lot of expansion to do for this question because they want all the terms up to x squared. So I'm going to start first with the constant term. The constant, remember we just look at one bracket and we just try to pair everything in that bracket with another bracket. Since both brackets have 3 terms, it doesn't matter which one I work with. So I'm going to work with this bracket here. I look at the first term here and I ask myself, what term can I multiply with in the second bracket to give me a constant term? There's only one option, which is 1 times 1 plus the second one is I want the x term. So the x term, there are more possible combinations. So again, I'll start with the first term here and I ask myself 1 times what in the second bracket to give me my x term, and that will be times negative 6x. So it's 1 times negative 6x. And then next I look at this one here, nx, and I ask myself who do I pair it with in the second bracket to give me an x term, and that will be with 1. So that is plus nx times 1. So plus, and then I look at this one here and I ask myself who do I pair it with in the second bracket to give me an x term, and it's not possible because this is already x squared and the second bracket will just increase the power of x. So that is all for my x term. Finally, I need to look at my x squared term. So again, I look at the first term, which is 1, and I try to pair 1 with something in the second bracket to give me x squared, and that will be with 9x squared. So 1 times 9x squared. Then plus the next one, I look at my nx term and I try to pair with something in the next bracket, which will be with negative 6x to get my x squared. So it's nx negative 6x. And finally, I look at this one and I try to pair it with, have to pair it with the constant term. So that will be plus n minus 1 over, I just write it as 2, this one times 1, okay, plus dot dot dot. Alright, with a lot of work, we have finally managed to get all the terms that we need. So the next step, we have to simplify all these. I'm going to simplify it very quickly. Okay, now I am ready to do my comparison, to compare coefficients. The question says that the coefficient of x squared is 3. That means I only need to compare this. So it says coefficient of this is 3. This gives me an equation that only has one unknown. That means I can solve it and get my n. So I'm very quickly going to solve this. But the question did say that n is an integer that is greater than 1. So I will reject this. Therefore, the answer is 12. The final example. In the expansion of 3 plus 5x to the power of n, the coefficients of x squared to x4 are in a ratio of 18 is to 175. Again, we want to find the value of n. So for this question, since they only want the coefficients of x squared and x4, I can actually use my general term. When choosing between whether I want to do an expansion or I want to use general term. To me, it's really a matter of which one is faster. Because if I do an expansion of these up to x4, I'm going to get the x to the power 0 term, the x to the power 1 term, the x to the power 2, x to the power 3, and x to the power 4 terms. And out of these terms, I don't need x to the power 0, I don't need x to the power 1, and I don't need x to the power 3. So I found a total of 5 terms. But out of these 5 terms, I only need 2 terms. Therefore, I don't think it's the most time efficient approach to use expansion. Cases like that, I think it's faster to just use the general term. So let's proceed. Okay, general term, n, choose r, 3, 5x, r, n minus r. Now I want the coefficient of x squared. So let me write down the x squared term. The good thing about this expansion is that there is only one bracket with x. So therefore, if I want x squared term, I can straight away see that my r should be 2. So let's write that down. N, choose 2, 3, n minus 2, 5x, 2. Now the next one, we will write down the x to the power 4 term. So x4 term. Again, using the same logic that we did just now, because only this one has x, so that tells me my r should be 4. And choose 4, 3, n minus 4, 5x to the power 4. Okay, I am now ready to get the coefficients. I only want the coefficients. From here, this one, the coefficient is just, basically you just take the x away, and the x and its power. Therefore, the coefficient for this is n choose 2, 3 to the power of n minus 2, and I take the x away, so I'm only left with 5 square, which is times, I can say it's times 25. The other one is, this is n choose 4, 3, n minus 4, and I take x away, so I'm left with 5 to the power 4. And 5 to the power 4 is 625. The question says that the coefficients of x squared and x4 are in the ratio of 18:175. We will write that ratio as a fraction. So I can say n choose 2, 3n minus 2 times 25 over n choose 4, 3n minus 4 times 625. 18:175, I will change it to a fraction. 18/175. Now I have one equation. In this equation, there's only one unknown, which is n. So we can solve the equation, but we need to do some manipulation first. Let us simplify this equation. I have 25 and 625. I can simplify it to 1 and 25. And then I have powers of 3. This one I can simplify using indices, because we have 3 to the power of n minus 2 over 3 to the power of n minus 4. My laws of indices says that if it's a division, I change it to a subtraction of the powers. So it becomes this. Here I'm using this law of indices here. A to the power of m over a to the power of n equals to a to the power of m minus n. That simplifies to 3 to the power of n minus 2 minus n plus 4. So it's 3 to the power of 2, which is 9. So this simplifies to 9, because 9 is the same as 9 over 1. Therefore, it tells me that 9 is actually in the numerator here. Now we can rewrite this whole thing. I have n choose 2 times 9 over n choose 4 times 25. 18/175. Let me bring this number and this number over. We can rewrite the left hand side as n choose 2 over n choose 4 times 9 over 25. Then I can divide it, which is the same as 18/175 times 25 over 9. That simplifies to 2 over 7. Now I simplified it to something that is a lot less intimidating. But I still have the n choose 2 and n choose 4. I can simplify these using my formula. So n choose 2 we know is n over 2, but there's 2 factors, so it's n minus 1 over 2 times 1. Over n choose 4 is n over 4, but there are 4 factors, n minus 1, n minus 2, n minus 3. Over 4 times 3 times 2 times 1. Here I'm taking a fraction divided by another fraction. I'm going to change it to a multiplication. That gives me n minus 1 over 2 times 4 times 3 times 2 times 1 over n minus 1, n minus 2, n minus 3, 2 over 7. And I can cancel n with n minus 1, n minus 1, 2 with 2 times 1. Now everything is much simpler. This becomes 12 over n minus 2, n minus 3, which is 2 over 7. Cross multiply. You shouldn't have problems solving these now. So let me very quickly write down the answer. So n equals 9 or negative 4. Now n cannot be a negative sign, at least for our syllabus, because our syllabus is only for positive values of n. So therefore we can reject this and we say that n is 9. With this, we've come to the end of our binomial expansion series. I hope you have found it useful. Thank you.